Okay, students, so now we're going to do a hypothesis test for a mean when sigma is known. And this is about blood cell volume, and I've went ahead and I've collected all the important information from the paragraph and jotted it down on the side. Now, it's important to note that this is a small sample size, but we can use a z-test for it because we know the population standard deviation. Since the population standard deviation is known, the sample size is irrelevant, okay? A lot of times when you have small sample size, you want to use a t-test, but a lot of times you don't know the population standard deviation. So we know it, so we're going to use a z-test, okay? So let's set up our hypothesis. H0 is, mu is the value they're claiming it to be. They were claiming, let's go back and look real quick. They were claiming 28, and I believe that was milliliters per kg. And then we were trying to see if the blood cell volume was different either way. So that's a two-tailed test, not equal to 28 milliliters per kilogram. Okay. The critical value, if you're doing the critical value method, you need to get in your z, and you need to look up your alpha level of significance, which is 0.01 in this problem. And we're going to be doing a two-tailed test because this symbol is not equal to, so we're going to have two tails. So let's get out our z table. Look up your critical value for a two-tailed test. When alpha is 0.01, it's plus or minus 2.58. Plot your critical values and shade your rejection regions. I like to label them, you don't have to. Okay. Now if you're doing the p-value method, your graphing calculator can spit you out a p-value if you ask for a z-test. So the p-value it's popping up is 0.0088. Back to the critical value method, you guys have to do a test statistic. So you're going to plug in your sample mean, 32.7, minus your mu, the mean they are claiming, 28. Divide that by sigma, 4.75. Divide that by the square root of n, which is 7, and you should be getting a test statistic of 2.62. And then you have to see where that falls in your picture. Does it fall in your rejection regions? Well, it does. So you will reject H0 based on that. Now, you p-value people, you just have to compare that p-value to your alpha value and see if it's less than. If it's less than, you reject. This p-value is indeed less than. So on both scenarios, whether you're doing the critical value method or the p-value method, you will come to the same decision, which is to reject H0. And then you just have to write your conclusion. Based on the evidence, the mean red blood cell volume is significantly different. I left myself lots of blank spaces. Different than we were claiming 28 milliliters per kilogram at an alpha of 0.01. Okay? And that's all you do. And again, that was a hypothesis test for the mean when sigma was known. So it was a z-test.